We're going to work on an ALEKS problem, which is finding a molecular formula for molar mass. And when we're asked to find molecular formula, there should be a few steps we need to cover. For the first thing we want to do is convert each element's mass to moles, and then we want to set up a ratio. We want to make sure that the ratio gives us whole numbers. From there, we can determine the empirical formula. Once we have the empirical formula, we can go ahead and find the empirical formula mass, and then calculate n, which is the factor we use to multiply the subscripts. Once we have that, we can go ahead and determine the molecular formula. Let's take a look at an example that comes directly from ALEKS. This question states that compound X has a molar mass of 266.64 grams per mole in the following composition. So they're giving us the mass percent of the different elements, and we can think of the compound as being 100 grams. So if aluminum makes up 20.24% of that 100 grams, then we can just say that aluminum is 20.24 grams. So the first step is to convert grams to moles, and you want to use the periodic table that ALEKS provides. And chlorine makes up 79.76%, so we can just think of that as grams. And this 35.446 grams comes from the periodic table of ALEKS. The next step is we want to set up some ratios, so aluminum to chlorine. So aluminum's moles is 0.7501. Chlorine is 2.250. We want to divide by the smallest number. So this is a 1:3 ratio. The 1:3 ratio tells us that the empirical formula is ALCl3. So this is called the empirical formula. So we got to keep going because they're asking for the molecular formula. The next step is to find the empirical formula mass. So we're going to go ahead and use the numbers that we've been playing with. So there are 3 chlorines and 1 aluminum. Grams per mole. Once we have that, we can go ahead and try to determine that factor, that n. The formula for that is molar mass over the empirical formula molar mass. So n equals, the molar mass of this compound is in the story problem. The empirical formula mass is what we just determined. So n equals 2. That n equals 2 means that we multiply the empirical formula by 2. So our molecular formula is going to be Al2Cl6. Let's take a look at another example. This example states that compound X has a molar mass of 283.89 grams per mole and the composition of phosphorus and oxygen. So the very first thing we want to do is convert our masses to moles, and we want to make sure that we're using the periodic table that ALEKS provides. And oxygen, we're going to convert 56.36 grams to moles. The next thing we want to do is set up a ratio. Phosphorus to oxygen. And this gives us a 1 to 2.500 ratio. Our ratio has to give us whole numbers, so we're going to have to multiply by the lowest integer to give us those whole numbers. So if we multiply by 2 on both sides, we get a 2 to 5 ratio. So that tells me that our empirical formula is going to be P2O5. This is our empirical formula. The next thing we want to do is figure out the empirical formula mass. There are 5 oxygens. And 2 phosphorus. The next thing we want to do is plug into the formula to find N. Remember, N is the molar mass divided by the empirical formula molar mass. The molar mass is in the story problem. The empirical formula mass is what we just calculated. So N equals 2. We come back to our empirical formula and we multiply this by a factor of 2. So our final answer would be P4O10. Good luck and keep practicing.